systems engineer Melody Martinez out at Slick 41 following the rocket roll to pad. Let's take a look. We just saw the Atlas V with AFSPC-11 roll from the VIF to the pad. Melody, with such an exciting launch ahead of us, what can you tell us about Eagle once it's on orbit?
Well, to begin, the primary mission objective for the Eagle platform is to demonstrate a maneuverable ESPA-based space vehicle design which can accommodate 6 or more hosted or deployable payloads in geosynchronous orbit. Furthermore, the ESPA-based platform concept can be cost-effectively replicated for multiple payload missions to any orbital regime.
Wow. What can you tell me about how Eagle got started?
Well, the Air Force Research Laboratory, or AFRL, Space Vehicles Directorate has continuously conducted on-orbit experimentation for over 20 years. Eagle was selected in 2011 to advance space access, improve resiliency, and increase space situational awareness. Additionally, the Eagle platform is a test bed to develop and train Air Force space professionals to improve future space warfighting and lay the groundwork for future ESPA-class missions.
You mentioned experiments. Can you tell a little bit more about what those will do once on orbit?
Sure. So each payload has its own scientific objectives. A summary of the payloads include armor, a suite of sensors for local area awareness and sensing to assist in on-orbit anomaly resolution. Included sensors are optical and particle detectors for space weather. There's HTI, an optical detector. There's Mycroft, a follow-on experiment building on the results of Angels that will investigate its advanced guidance, navigation control, and flight safety methods at geosynchronous orbit. And there's ARCS-1 and ARCS-2, which are separable payloads.
What's unique about Eagle's capabilities?
Well, the AFRL Space Vehicles Directorate's mission is to develop and transition innovative, high-payoff space technologies supporting the warfighter, while leveraging commercial, civil, and other government space capabilities to ensure America's advantage.
What are some of the advancements that Eagle has compared to some of the prior experiments?
Well, prior AFRL Space Vehicle Directorate programs advanced safe spacecraft operations, as well as space situational awareness technologies and capabilities in various orbital regimes. The primary mission objective for the Eagle platform is to demonstrate a maneuverable ESPA-based space vehicle design which can accommodate up to 6 hosted or deployable payloads in geostationary Earth orbit and can be cost-effectively replicated for multiple payload missions to a geo, low Earth orbit, or geostationary transfer orbit.
Thank you so much for taking some time to talk to me about Eagle today, Melody.
No problem. Glad to be here.
The artwork on the payload fairing of this evening's rocket consists of an Atlas V 551 rocket launching from Cape Canaveral Air Force Station. The dial is turned to 11 to capture the spirit of the AFSPC-11 government launch team and its mission, which is to maximize efforts to meet Department of Defense requirements to support our senior leaders and combatant commanders with war-winning space capabilities on time and on schedule.
Verified. LC, this flight control.
Go flight control.
Launch on time verified.
Roger. All steps are complete prior to status check. LC switch to ready position.
We remain in the planned 15-minute built-in hold as we continue to prepare for liftoff. In a few moments, launch conductor Scott Barney will poll the launch team for the final go to pick up the countdown. 28 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Scott Barney performs the final polling of the team.
Status check to proceed with terminal count. Respond go, no go. Atlas Systems, propulsion. Go. Hydraulics. Go. Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur Systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
ASGAS.
Go.
Electrical Systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
BSC is go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
The CMD, you have permission to launch.
Proceeding with the count. ALC verified T0 is set for 2313 Zulu.
Verified.
Polling is complete and the launch team has given the go for launch. From T-minus 4 minutes until launch, you will be listening to Launch Conductor Scott Barney and his team performing the final steps in the countdown procedure. You will hear the team call out that Atlas LO2 topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute and 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute and 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed by verification of Centaur tank pressures. A final status check of Atlas, Centaur, and AFSPC-11 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear the voice of Patrick Moore providing launch vehicle ascent data. This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. 3 minutes 55.
Ground pyros enabled.
The countdown clock has resumed and we are go for launch at 7:13 p.m. Eastern.
T-minus 3 minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
2 minutes 50 seconds.
FTS internal.
Two minutes 10 seconds.
Eagle on internal power. Roger.
$159.
Vehicle internal.
155,
Launch sequencer start.
150,
Securing Centaur LH2.
Securing Centaur LO2.
140,
Launch enabled.
137,
STS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120,
OCUs armed.
SCS count started.
115,
Reduce ECS for launch.
Roger.
110,
Vent valves locked.
T-minus 1 minute.
T-minus 1 minute.
Rock. Report range status.
Range green.
T-minus 40 seconds.
Stable at step 3.
.28 seconds.
ECS reduced for launch.
Roger.
25,
Status check.
Go Atlas.
Go Centaur.
Go AFSPC-11.
T-minus
T-minus
10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1. And liftoff of the United Launch Alliance Atlas V rocket with AFSPC-11 for the United States Air Force.
180 pump speeds and injection pressure. And good chamber pressure across all 5 SRBs. PU's gone to closed loop control. Now passing 20 seconds into flight. Continue to see good pump speeds and injector pressures on the RD-180. 30 seconds in. And vehicle's now passing Mach 1. SRB chamber pressure continues to look good across all 5 SRBs.
You are hearing the
Now
voice
passing
of
max
Patrick
Q,
Moore
maximum
providing
dynamic
launch
pressure.
vehicle ascent data.
And pump speeds and injector pressures on the RD-180 continue to look good. SRB chamber pressure is also looking good. Now passing 1 minute into flight. And the launch vehicle is now 11 miles in altitude, 7 miles downrange distance, traveling at 2,300 miles per hour. 1 minute, 15 seconds into flight. And we should be expecting SRB burnout momentarily. Chamber pressures on the SRBs tailing off. And we have burnout on all 5 SRBs. 1 minute, 40 seconds into flight. RD-180 pump speeds and injector pressures look good in full thrust mode. And we have good jettison of all 5 SRBs. Vehicle's gone to closed loop guidance. Now passing 2 minutes into flight, Mach 5. And pump speeds and injector pressures on the RD-180 continue to look good. Vehicle is now 40 miles in altitude, 55 miles downrange distance, traveling at 4,900 miles per hour. And now passing 2 minutes, 30 seconds into flight, approximately 2 minutes remaining in the Atlas booster phase of flight. And the RD-180 is now throttling down to maintain a constant 2.5 G acceleration limit. Engine response and vehicle acceleration response looks good. And the RCS pyro valve is unfired. Reaction control system is now pressurizing the flight levels. Now passing 3 minutes into flight. and seeing good response on the RD-180 pump speeds and injector pressures as vehicle throttles down to maintain that acceleration limit. And we're standing by for payload fairing jettison momentarily. And we have good indication of payload fairing jettison. And we have good indication of CFLR jettison. And vehicle's now throttling back up to full thrust. RD-180 response looks good. And now passing 4 minutes into flight, and the RD-180 is now throttling to maintain a 4.6 G acceleration limit. And the Centaur has begun the boost phase chill down sequence. Pump speeds and injector pressures on the RD-180 continue to look good. Vehicle is now 90 miles in altitude, 328 miles downrange distance, traveling at 13,000 miles per hour. And standing by for BECO momentarily. And we have BECO boost turned in cutoff, standing by for stage separation. And we have good indication of stage separation. We have pre-start on the RL-10. And we have ignition on the RL.
This is Atlas Mission Control at T+5 minutes. Patrick Moore just confirmed the successful completion of the early phase of today's flight, and all systems continue to operate nominally. In addition to learning more about the Eagle bus, which is on its way to orbit at this very moment, I also had the chance to meet with Major Liz Deneve, Eagle Systems Engineer, to hear about Mycroft, one of the 6 payloads attached to the Eagle bus. Major Deneve, what's the objective of the Mycroft payload?
Well, the Mycroft will investigate advanced guidance, navigation and control, and flight safety methods at geosynchronous Earth orbit, or GEO. Additionally, the Mycroft experiment will advance key technologies supporting a self-inspection capability and explore new and responsive ways to improve the timeliness of orbit determination for threat warnings at GEO.
Can you tell me a little bit more about self-inspection capability?
Well, self-inspection is just as it sounds. It's inspection of one's own spacecraft. In this case, Mycroft will inspect the Eagle spacecraft. If our spacecraft was experiencing an anomalous behavior, perhaps the output of the power system is less than expected, a timely self-inspection capability would help us to determine the cause. Perhaps the solar arrays didn't fully deploy. The Air Force continues to pursue, adapt, and evolve the unique technologies, innovative techniques, and diverse applications that give the United States its strategic advantage in space. Many of these technologies are restricted by export control laws. The Air Force is protecting United States technologies that may play a role in future operational capability and maintain the strategic advantage in the increasingly congested, competitive, and potentially contested space environment.
Wow. Can you tell me a little bit more about some of Mycroft's unique capabilities?
Yes, the Air Force AFRL Space Vehicles Directorate's mission to develop and transition innovative, high-payoff space technologies supporting the warfighter, while leveraging commercial, civil, and other government space capabilities to ensure America's advantage. Mycroft will advance key technologies supporting a self-inspection capability and explore new and responsive ways to improve the timeliness of orbit determination for threat warnings in GEO.
Tell me a little bit more about some of Mycroft's operations.
Well, Mycroft will conduct safe proximity operations with the AFRL Eagle spacecraft. It will operate within 10 kilometers of the Eagle ESPA ring within approved policy limits. AFRL protects technologies, performance, and capabilities so they are viable for transition to the operational systems.
How does the AFRL transfer technology?
AFRL transitions knowledge, products, and vision to our customers. This not only includes hardware and software for space applications, but also the know-how to achieve new space capabilities. Furthermore, AFRL provides concepts that address the potential future space environment. AFRL responds directly to customer technology needs as well as leads discovery of new innovative technologies.
Thanks for coming in and speaking with me today.
Thanks for having me.
I'd like to thank Patrick Moore for his support for today's show. If you'd like to know more about the Atlas V, please visit ulalaunch.com or visit us online at Facebook and Twitter. We'll complete our live coverage with another look at today's liftoff, which occurred at 7:13 p.m. Eastern Time. I'm Tyler Strickland, and on behalf of the entire launch team, thank you for joining us, and have a great night. And liftoff of the United Launch Alliance Atlas V rocket with AFSPC-11 from the United States Air Force.
Pressure across all 5 SRTs. PU's gone to closed loop control. Now passing 20 seconds in flight. Continue to see good pump speeds and injector pressures on the RD-180. 30 seconds in. And vehicle's now passing Mach 1.